JavaScript Decorators. You can find these slides at the URL right there, and all the code examples that I'm going to show are in that GitHub repo. That's actually a repo for a book that I'll talk about in just a second, and there are many code examples for topics other than decorators, but the ones you want are in a directory called ch05, and that's because I talk about JavaScript decorators in chapter 5 of my book. So about me, I'm a partner and a software engineer at a company called Object Computing in St. Louis. I've been doing this for a long time. I write about a lot of things and I speak as often as I can. I have a blog at that URL, and I've written 3 books, the most recent of which is in early access right now from Manning, and it's about developing web components, and it goes through how to write them in the vanilla form and then using a bunch of libraries like Lit and Stencil and Fast and my own library called Rec, which I talked about yesterday. So if you're interested in that, there's a code for getting the book for 45% off. Interestingly, right now, you can get it for 50% off when you go to the site. So I guess don't use that code, but that QR code will also get you there. So what is a decorator? Well, it's a design pattern and a syntax that lets you wrap a piece of code, and you don't have to change the code. It's like from the outside, you're changing the way it's going to behave. And you can apply decorators to functions or classes or properties of a class or methods in a class. But in the world of JavaScript, you can't do this to a function at the moment. It has to be a class or something defined inside the class. Decorators are supported by many different programming languages, all the ones that you see up there. So this is not a new concept by far. So why should you consider using decorators? Well, there's nothing that a decorator can do that you couldn't achieve in some other way. You could just write a function, and when you call the function and pass it this thing, it takes some of the same actions that a decorator would take. But I think decorators are useful for 2 main reasons. One is that they reduce boilerplate in your code. And another is that they make the code more declarative. And this is where it would differ from just writing a function to do a thing, is that you're attaching it to a specific thing in your code, like one method, and you're saying, I want this method to behave differently in this specific way. And so you're stating a goal instead of exactly how you're going to achieve that. And I try to put interesting graphics up in the corner of my slides, and I wonder if anybody knows why I put that graphic there. It's a picture of the singer Annie Lennox. Well, one of my favorite songs by her is called Why, and it goes with the slide. So there are a lot of reasons why maybe you want to avoid using decorators. One is that they introduce a kind of magic. You see this decorator applied and you're wondering, oh, what does it do? And just by applying that decorator, you've changed the functionality of that thing in a way that maybe is difficult to follow. And why is it difficult to follow? Well, it's not like there's a sequence of function calls that you can easily walk through. You don't click it in your IDE and it takes you to a definition. And so the code that implements that decorator might not be easy to find, and it might not be well documented. And this is the reason why a lot of people prefer not to use decorators. And I should point out that there have been times in my career where I thought that I didn't like a particular technology, but I wasn't exactly sure why, or I couldn't articulate it. And so I bought a book to learn more about that technology. And after reading the book, I determined, yeah, I don't like that. And now I understand exactly why. And that might be your reaction to this talk. You might come out of this thinking, I don't really like decorators. That's success, right? Now you know exactly why you don't like it. Of course, I hope the opposite is true and that you really think decorators are a valuable thing for you. So why should you learn how to implement your own decorators? Well, most likely, the majority of the decorators you're going to use are ones that other people implemented. You're just using them. But if you learn how to implement them yourself from scratch, you'll have a better understanding of what's happening behind the scenes, just a better appreciation for them. Now, you're probably aware that the JavaScript programming language is standardized by this group called ECMA International, and the standard is called ECMAScript. And they've already standardized the use of decorators in JavaScript, or they've described it. And this happened way back in 2015. that we refer to as the Stage 1 Decorators proposal. And they're called legacy decorators now, and you really shouldn't keep using them. But there are a lot of software libraries that still use that kind of decorator, and you can tell TypeScript explicitly in your tsconfig file that I want to use the legacy kind. But that's not what we're focused on here. We're focused on standard decorators, which are the Stage 3 proposal, preferred over the legacy decorators. And I really hoped that before I gave this talk, that when they announced what would be in ECMAScript 2026, that decorators would be there. And I could tell you in this talk, they're now an official part of the JavaScript language. Unfortunately, they did not do that. And so maybe we'll see it in 2027. However, even though it's not really a standard part of JavaScript yet, they're still used in many places. And number one has to be the TypeScript compiler itself. That supports decorators already. And so does the Vite tool that you could think of as a build tool and also a development server. The alternative JavaScript runtimes, Bun and Dino, both support decorators now. Angular has supported decorators for a really long time, since 2016. And then the reason that I got into this, the reason I'm giving this talk today, is that I was writing that book about developing web components. And it turns out that a bunch of the libraries for that, Lit, Stencil, and Fast, they all use decorators. They define their own, and then you use their decorators when you're implementing web components. So decorators are not yet supported in web browsers, and they're not supported in Node.js, but that doesn't mean you can't use them in those environments. It just means you need to use something like maybe TypeScript to compile your code that uses decorators into new code that doesn't use decorators but does the same thing, and then you run that code. So what can a decorator do? Well, basically three things. It can access information about the target that you've applied it to, just get information about it. It could initialize it. In the case of a field, your decorator might specially initialize that field to a certain value, and not necessarily a constant. It could be something that changes based on some logic inside the decorator. But I would say the most common use of a decorator is to replace the target. And I'll be talking about when you might want to do that. And I guess that's right here. When you apply a decorator to a class itself, not to individual fields or methods, then you have the option of having the decorator return a brand new class that extends the one you've decorated, and then it's adding some functionality to that. When you apply a decorator to a method inside a class, you could return a brand new method that does something different. Now, most commonly, it would not only do something different, but it would also call the original one, kind of wrapping that original implementation. If you apply a decorator to a field inside a class, well, then you can get a hold of the initial value that was assigned, and you can return this object that has a getter and a setter. So those are special methods in JavaScript that get invoked automatically anytime you would access that field or change its value. So for example, in the setter, you could do some validation and make sure that if you're trying to set this field to a value that's not valid, you prevent that from happening or maybe throw an error. So if you want to replace the target, remember the target could be a class or a field or a method. If you'd like to replace it with some new thing, then you just need to return something of the same type. Return a new class or return a field definition or a method. If you don't return anything, then the target remains unchanged. And that's valuable too, especially in that first case where your goal is just to access data. Maybe you're logging it somewhere. You don't want to change it. You're just trying to get to some data. And so then your decorator wouldn't return anything. If you want to apply a decorator to some target, the syntax is @ and the decorator name. And somewhat shockingly, you cannot pass any arguments to a decorator. Now, at first glance, this seems incredibly limiting. But the solution to this is that you apply not a decorator, but a decorator factory. And I'll show you examples of those near the end of my talk. A decorator factory can be passed data. Its job is to return a configured decorator. So that's your second option for applying these. And you can apply more than one decorator to the same target. So if we're talking about a class and I apply multiple decorators, well, maybe one of them is adding a couple of methods with a very specific purpose for that decorator. And then I apply a second one, and that's adding other methods or changing methods. And so each decorator has a specific purpose, and more than one can be applied. So decorators are applied when a class definition is parsed, not when you create instances of that class. And so it's important to know about the timing of this based on what your decorator might be trying to accomplish. So when you apply decorators to a class and to the things inside it, like its members, its fields, and its methods, the ones for the fields and the methods are applied first, and then the ones applied to the class happen. And why do you care about this? Well, as we'll see toward the end, it's possible to have decorators that are accumulating some data, and then later you're going to do something and work with that data. And so you might care about what order these things are running in. All right, so enough talk about the nature of these things. Let's look at an example of one of these. So let's start with a simple class game that has one field, score. That pound sign means that it's a private field. And I have a getter and a setter method for that. The getter simply returns the value of that field. And the setter is doing some validation. I don't want you to set the score to a negative number. And so if you try to do that, I'm going to throw an error. But otherwise, I'll assign that value to the private field. And then I can use it, as you see over in the lower right. I'm pulling in my game class, and then I create one instance of that. And then inside a try block, I set the score to 7. That's good, not a negative number. But then I try to set it to -1, and that's going to throw, and I'm going to end up down in the catch and print out that error message, score cannot be negative. Well, there's nothing wrong with this. It works great. But we can improve this by using a decorator. And the concern here is that for a one-off, this is fine. But what if I have many classes in my application with many fields that are numeric like that and they can't be negative? I don't want to repeat that logic and have to write all of those setters. And so what I could do instead is come up with this decorator called non-negative, and I'll just apply that to all of the setters for my numeric fields, and they don't have to do any error checking because the decorator is going to do it for me. Well, we haven't seen the code for this yet, so let's take a look at that code. Now, this is implemented in TypeScript, and so that means I'm going to have a lot of types. And it means I'm probably going to use the scary generics, like what's going on here? That non-negative has that generic parameter there, this. And then my decorators take two arguments. A target is what I'm applying it to, and then a context. Now that target there says you must apply this to a function that takes a number and it doesn't return anything. And that's exactly what setters do in JavaScript. So I can apply that to a setter. And further, I'm specifying that on the context object, and we're going to see a list of the classes that you can use there coming up soon. But it's not only a setter, it's a setter that is applied to a class that matches this. And we haven't seen yet where that's coming from. But then I'm returning a new setter method. And I know it's a method because it has a this. That's called a fake this method of writing a function that operates on a specific kind of object. The most important thing is that it's getting a new value, and I'm checking to see if that new value is less than 0. And if it is, then I go back to my context object, which has many properties on it. We're going to talk about those later. But for now, the one we care about is that the context knows the name of the target we've applied this to. And in our case, the value of name is going to be score. We applied it to the score field. It's a symbol. Context.name is a symbol. And so if I want to use it as a string, I have to convert it to a string as I'm doing there. And then I'm throwing the error and saying, in this case, score cannot be negative. Finally, if I don't throw an error, then I want to call the original setter. And so I tell the target, I want to call on the object this, and pass it the new value. So that target is the setter method. Okay, a little bit messy to write, admittedly, and this might be a reason why you're not crazy about these decorators, but you get used to this idea after a while that all the decorators take two things, the target that you're applying it to, and a context that describes some things about that. And so in our case, the value of the this generic parameter is going to be our game class, and the target has to be a function that takes a number and returns nothing. Yeah. Okay. And then we're returning a new setter method that is going to replace the original, and it delegates to that original one. Okay, so we've said that decorators are functions that are passed two things, the target to which it's applied and a context object. Interestingly, when you apply a decorator to a field inside a class, the target parameter is always going to be undefined. And so that's just not something that's useful when you apply it to a field. And the reason that this is happening is because the fields don't actually exist on the class yet until you've instantiated the class and you've created some objects. Well, the context object has a different type based on what you apply it to. All of these context types have a name that begins with class and it ends with decorator context, but here's a list of all of them. And so when you're writing your decorators, you have to use the correct context type based on the kind of target you're applying it to. And then that context object has a name property, and the name property is going to be one of those strings. And you could check that inside your decorator and maybe throw an error if a developer tries to apply your decorator to the wrong kind of a target. Okay, so a context object has a lot of properties, many of which I'll talk about later, but the important ones for now is that I can get the kind and the name. So those are both strings that are present in all the context objects. So kind is from that first column in the table on the previous slide. I could use that to verify that you've applied it to the right kind of target. And then name, interestingly, sometimes it's a string and sometimes it's a symbol. And so the safe thing is let's just assume it's a symbol. And then if we want to use it as a string, you pass it to that string constructor and convert it to a string, as you saw in that previous example. So when a decorator is applied to a class, the value of kind is going to be a symbol set to class, and then the name is going to be the name of the class that I applied it to. All right, so let's look at another example. I want to write a decorator that can log information about a field, and it's going to return a function that will be past the initial value. And so I could just log out the initial value. Not a particularly interesting example, but what's kind of interesting about this is that it can conditionally assign a different value, conditionally changes it. Go back here. So we see that happening down here, that this function I'm returning will be past the initial value that's assigned to that field, and then I'm just logging it out. And then I say if it was really the string random, then what I'm going to do is generate a random number and convert that to a string and return that. And in any case, at the end, I'm returning that initial value. And so I have an opportunity in this kind of decorator to say, if you give me a value, an initial value that I don't like or I need to change, I could do it in this decorator. And so here's what that would look like in code. I have this class secret. It has one field called code, and I did set it to random, and then I applied my decorator. And so here I created an instance of that class, and that alone is going to cause it to output the initial value of the code field is random. My decorator did that. And then if I print it out, I'll see it really did generate a new value for me, and I'll get some random value generated. Okay, so that's one kind of decorator. Another really interesting thing about the standard decorator proposal is that it adds a new keyword to JavaScript. And that is the accessor keyword. And I put this in front of a field, and it will generate those get and set methods for me. So it makes it so that I don't have to write them. Interestingly, though, typically if you want those, you want them because you want to do something special inside them. You don't just want some default behavior. So really the primary motivation here is that I'm not only going to generate the accessor methods, but I also want to apply a decorator to it. So for example, here I'm back to my game class with my private field score that starts at 0. And here I've got the get and set methods that I have written manually. But these aren't doing anything special. The getter just returns the field value, and the setter is just setting it to some new value. But if I use the accessor keyword and I apply it to that field, that is exactly the same as this. So if all I want is to generate these basic forms of getters and setters, I just have to apply the accessor keyword. Once again, it's not particularly valuable unless you're going to apply a decorator to that and do something special. So what could a decorator on an accessor do? Well, we're going to look at one called log access on the next slide. As you might guess, it's going to log out every time I access it, every time I get or set the value, you'll see that output. Maybe a more interesting example is range validation. So I could say on a field, yeah, I want you to generate accessors, but this is a number and it has to be between 20 and 47. So we'll see an example of that coming up later. I also could lazily compute the value every time you ask for it. It could do something as crazy as hitting an endpoint on a server and fetching the value, and then that becomes the value that I return in a getter. Thinking about web components, sometimes when the value of a property changes, you need to notify a library, hey, something changed, and so you need to update the UI or re-render some part of it. And so that would happen in a library like lit, and I could use an accessor to let lit know that the property changed. All right, so let's look at what I would do if all I want to do is log out every time I access a field, either getting or setting. And so here's what that decorator would look like. Log access, and notice I have two generic parameters there. This is telling me about the target that I've applied this to, the accessor field itself, and then a value is the type of that field. So my target is something that matches class accessor decorator target and using those generic types. Once again, when we're using TypeScript, there's a lot of types involved, including generics, and it starts to look a little bit scary. But the second parameter, remember, is the context object, and I only want two things out of that. And so I'm destructuring that and pulling out kind and name. And then I'm doing some of my own error checking at runtime, and I'm saying if the kind of the thing that you applied this to is not an accessor, you're using this incorrectly, and I'm just going to throw with that error message. But as long as you applied it to an accessor, I'll take the name, which is a symbol, and I'll convert it to a string. And then my job is to return new getters and setters. So I'm returning an object that has get and set methods that know about the type of the object I've applied it to with the this there. And then for the getter, I'm just going to call the original getter and get the value. And then I'm going to log out what the value is and then finally return the value. And so I've just wrapped the existing getter method. And I'm going to do something similar with set. I'm logging out what the value is that I'm setting it to, and then I'm calling the original setter method. So with that in hand, I can use it like this. I can create a dog class that has a name and an age, but the age has a generated accessor, and I applied my decorator to that. And when I create an instance of a dog, it's just storing its name. And so the age is going to start out at 0. And so here I've created my dog object. And when I set the age to 5, it's going to output that message because my decorator is intercepting all the calls to setters. And then when I just output it, it's going to say, well, I just accessed that. And so I was getting the age field, and it tells me what its value is. So this could be useful for debugging an application. You could just temporarily add that decorator, and when you're finished debugging, you could remove that. Another common use of decorators is to measure how long it takes for methods to run. And that's exactly what this decorator is going to do. And so I want to apply this to a method, and it's going to return a new method that wraps its execution so I can output how long it took. So over here, my target is the original method, And since you can apply this to any method, I need to be very generic about how I describe this. Now, in my generic parameters, I know what kind of object this method belongs to, and I know what the return type of the method is. And so that allows me to say that the target is a function that takes any number of arguments of any type, and it has the correct return type, the same as the method that I'm applying it to. Once again, I'm destructuring the context object and pulling out the kind and the name, and then I'm making sure that you applied this to a method. If not, I throw the error. Then I convert the name, which is a symbol, into a string, and now I can return the replacement for the method. And that method knows about this, and it has some arguments, and it has the right return type. And then I can use console.type time and pass it the name of the method. Then I call the original method, and finally I'll call console time end, passing it that same string, and that's going to cause it to output a message telling me how long it took for that to run, and then finally I return the result of calling that method. So with that decorator in hand, I can use it like this. So I have this class called MathLab that has a static method called Fibonacci. And as you're all probably familiar, one way to compute Fibonacci numbers is that function you see at the top. Well, I'm not applying a decorator to that function. And why am I not doing that? Because I can't. Because in JavaScript, you cannot apply a decorator to a plain function. But I can apply it to a method. And that's really what I want to do anyway, because I don't want to time the individual recursive calls. I want to time the whole thing. And so that's what I'm getting when I apply the time method decorator to my static Fibonacci method. Okay, and then outside my class definition, I can just call that static method, and it's going to print out not only the result, but also tell me about timing. And so this is the kind of output I'll get. It'll tell me how long it ran, and then it'll tell me the value of that Fibonacci number. Okay. So really easy to add timing of your methods. And like the previous example, maybe I'm doing this for debugging, and when I'm finished, I'll just remove that time method decorator. Another thing you might be interested in is counting how many instances of a class that you've created. So here, I'm going to apply this to a class, and then I'm going to return a new class that extends the original one, and it's going to add a static field called _instance count. And then every time an instance gets created, I'm going to increment that counter, and then later I can get the value and I'll know how many instances I've created. Okay. Well, one tricky thing about this is what is the type I should use to describe any class? And it turns out what I have to describe is the constructor of a class. And so here's how I would describe that. It's a new method that takes any number of arguments of any kind, and it returns an object. So I can use that as the type of my target in my decorator. And now I can apply this to any class. And then I am destructuring the kind property out of my context object. And if it's not class, I'm going to throw that error. And then I'm returning a brand new class that extends my target class. And so it has everything in my original class, but I'm adding this static property. And I should have changed this right here to a £. It's a private static field called instance count. And then I'm going to supply a new constructor. It's going to begin by calling my superclass constructor, which is the original class I'm applying this to. Okay, and then I want to increment my instance count field. It's interesting how I have to refer to that thing. If I say this dot constructor, then I'm getting a hold of the constructor for this class, and then TypeScript is going to force me to say as any to make this work. So I've got the incrementing in place, and then finally I add a static method. It's a getter for instance count. It just returns the value of that static field. So with that in hand, I could use it like this. Going back to my dog class, I've got a name property and a constructor that just sets it. And I've added that decorator, so I'm keeping a count of the instances. And then here I'm going to create an array of dogs. And so I create 4 different dogs. And as you might expect, when I'm finished, I can access that instance count static property, and it's going to tell me I've created 4 dog objects. I mentioned that there are many more properties on that context object that you can use, and I think using these are less common than getting to the kind and the name properties, but I'll just review these quickly for you. One of them is a property called static, and it's a Boolean that tells you, did you apply this to a static method or a static field? Another one is private, and this tells you in the case of some member of the class, uh, can your decorator access it? Because if it's private, your decorator can't get to it. So you might need to check those. Add initializer is actually a method on the context object that you can call any number of times, and you pass to that a function which is going to be called after the target is fully initialized. This is maybe especially important for a class because the things that you want to do in the decorator, it might not be appropriate to do those at the time the decorator is evaluated. You might need to wait for the whole class to get parsed. And so this is a way to say, yeah, my decorator wants to do a thing, but I like to wait until my target is fully initialized. So as I said, you can call this any number of times, maybe for different purposes, and then all of the functions that you register would be called when that target is fully initialized. And if you want to see an example of this, there's one, a decorator called custom element later, which is a decorator that the lit library supplies. And I show on that slide how you could make use of add initializer to implement the same thing yourself. There's also a property on the context object called metadata, and the most important use of this is it allows you to have multiple decorators applied to different things in your class, but they're all storing away some data so that later you can get to that shared data. There are many reasons that you might do this, but one that I show in the bonus slides that are at the end of this deck that I won't have time to go over, unfortunately, is a way of doing validation on a form. Sometimes when you're filling out a form, rather than it telling you as you enter each piece of data, hey, that's wrong, sometimes what it does instead is it's validating them, but it doesn't give you any feedback yet. And then when the user hits the submit button, you could say, here's a list of all the things you've done wrong. So if you want your user interface to work that way, then all of the decorators that are doing the individual validations could be storing the problems on that metadata object. And then when they click the submit button, you can access that and get to that data. And so that's what I show on some of the bonus slides that are later. One other property is called access, and I gotta tell you, I've looked over this and I think I understand it, and this slide describes it. I don't think it's useful. I couldn't think of a single reason why I would ever use that. So that's why the bird is on this slide. It's telling me, don't talk about this. All right, now I mentioned in the beginning that you cannot pass arguments to a decorator, and that's very limiting, especially in that case I described earlier where I want to do validation on a numeric field, and I want to say, this is a number that must be between 20 and 47. Well, I've got to pass in those limits. And so that's where decorator factories come into play. It's a function, just like a decorator is a function, but what it returns is a decorator function. So a function that returns another function. And this is going to allow me to pass in arguments, and I'll use them to configure the decorator function that I return. I apply it in much the same way as a decorator, but I can pass arguments to it. And so here is that example where I want to validate a numeric field, and it's got to fit within some range. And so I've got my function range validation, and you see it takes 2 arguments. The min and the max are passed in, and then I'm returning a function which is a decorator function. And I know it's a decorator function because it has 2 arguments, target and context. Inside, I'll specify a validate function that you see down here is called in 2 places. And so validate, I just pass it a number, and it checks to see if it's less than the minimum or greater than the maximum. And if it is, then I'll get the name of that field out of the context, turn it into a string, and then I'll throw that error message. But if it's good, well, let's say, yeah, if it's good, then I'm going to, oh, let me take a step back. So that's my validate function. That's totally separate, and I'm going to use it down here. And this decorator factory is returning an object that has two methods on it, an init and a set, because those are the two places where I need to do this validation. You might be trying to initialize this numeric field to a number that is outside the range, and that's where init comes into play. Or later, you might try to set it to a value outside the range. So in the init, I'm going to be past the initial value, and I'll call validate, which might throw. But if it doesn't throw, then I'll just return the initial value. And then set is called when you try to set the field to a different value, and I'll be past the new value. I'll validate that, and if it doesn't throw, then I tell the target, which was the setter that you applied, or the field that you applied this to, that I want to set that field, and I'm using the call method in JavaScript to do that, and I have to tell it the object I want to apply this to, and then give it the new value. Admittedly, this is not trivial to write. You know, a month or two from now, when you decide that you actually want to do something like this in a project, what are the chances that you'll remember all these details? You just come back and look at the slides and find it, or maybe ask an LLM to write this decorator for you. So it's a bit messy with all the TypeScript things going on, but that's the way it works. And so if you want to make use of this, then here's what it looks like. Going back to my dog class, my dog has an accessor field called age that starts at 0. And then I'm applying my range validation factory and passing into it that the dog should be between 0 and 20. Then outside the class definition, I'm creating an instance of that class. So I've got my dog, and then inside a try block, I'm setting its age to 5, and that's good. It's in between 0 and 20. But then I set it to 50, and that's no good. And so that's going to throw. And I'll get this message, uncaught error, age 50, outside the range of 0 to 10. And so my validator produced that very readable error message for me. Okay, so to wrap this up, decorators can reduce a lot of boilerplate in your code, and they make your code more declarative. You're specifying with the name of a decorator that I want this thing to happen. I'm not telling you how it's going to happen. It's just make this happen on this target. I can't pass arguments to a decorator, but I can write a decorator factory that returns a decorator function that's already configured for me. And unfortunately, decorators are not currently a part of the official JavaScript standard. Maybe this will happen in 2027, but that doesn't mean you can't use them today, because all of those tools, especially TypeScript, support them now. So you always can compile your code that uses decorators to code that does not, so you can run it today.